Alright, this video I'm going to talk about the sum of a finite geometric series. So the example here is I have to find the sum of this summation. Now, the way I had to type it, it came out a little bit weird. This is the same as, your sigma, I equals 1 on bottom, and that 9 is on top. 6 times 7, I to the 1, the exponent. So, yeah, I know the title is Sum of a Finite Geometric Series, but if this was the problem on a quiz or test, you do not yet know whether this is geometric or arithmetic. So that is important to distinguish so you use the right formula. So the first thing I'm going to do is I'm going to figure out the first few terms. So I'm going to figure out when I is 1, that's the first term, I is 2 is the second term, I is 3, I is 4. So I want to figure out and make sure this is geometric. Now you might be able to look at the rule here and kind of say, hey, this kind of looks like a1 times r raised to the n minus 1. But say on a quiz or a test you forget that, then maybe it's good to go through this just to make sure, yes, this is in fact geometric. So when I is 1, that means I'm going to use this rule, but just plug in a 1 for I. So I'm going to have 6 times 7 to the 1 minus 1 power. Well, 1 minus 1 is 0, 7 to the 0 power is 1, so I get 6. You could type all that in a calculator if you really wanted to. 6 times 7, exponent 1 minus 1, hit enter, you get 6. And then the next one, so the first term there is 6. Say I want to find the second term, 6 times 7. Now I'm going to put 2 up there, 2 minus 1. And again, if you want to do this in a calculator to get this done quick, the way that would look is you would have 6 times 7, exponent 2 minus 1, hit enter, and you get 42 as your second term. And then you go and find the third term. So we're going to have, that's a little bit, there we go. 6 times 7 to the 3 minus 1. And when you do that in the calculator, you're going to get 294. And then if you want to find the fourth term, 6 times 7 to the 4 minus 1, you're going to get 2,058. So that's my first term, second term, third term, fourth term. So looking at these, I need to figure out, well, is this arithmetic or geometric? Well, arithmetic would mean you add the same thing every single time. So to go from 6 to 42, I'd have to add 36. If I went from there, I'd have to add 36 again. Oh, that's not going to work. So then to check to make sure it's geometric, I need to figure out, well, what did I multiply it by every single time? So 6 times what gives me 42? Well, you actually multiply by 7. So using a calculator, well, what's 42 times 7? Well, that's 294. 294 times 7, 2,058. So I know, since we have this constant multiplier, I know I'm dealing with geometric. Because we know this, I know which formula to use. And the formula for a finite geometric series is going to be Sn equals a1, and then parentheses 1 minus r to the n divided by 1 minus r. So what this means is I'm finding a sum, and n represents, well, how many terms are you finding a sum of? Well, looking at my original problem, I started with I equals 1 all the way up to 9. So I'm finding the sum of 9 terms. So I'm finding S of 9 equals, well, A1. A1 represents the first term, which, oh, I found it. It's 6. We're going to have 6. And then go over here, I have a 1 minus R. R is your common ratio, which, oh, we found that too. The common ratio was 7. The n is still 9. So I have 1 minus 7 to the 9th power divided by 1 minus 7. And all I have to do is I have to figure out what this number is. Now you can go through and carefully type this all in a calculator. It might get a little bit messy. That's why I kind of suggest going piece by piece and just write it down on your paper. So what I would do is figure out what that top piece is. So I'd figure out 1 minus 7 to the 9th power is. And I get a big old number there. There it is, negative 403,53606. So I'd write that down. So I have 6 times negative 403,53606 divided by, well, 1 minus 7 is negative 6. So what I'm going to do in my calculator is I'm going to take that number, which I already have typed in, divide by negative 6. So what I'm doing is I'm doing the inside the parentheses there. Divide by negative 6. So I know this entire parentheses is that number, but I still have to multiply by 6. That is my final answer. 403,53606. So 40,353,606. So what I just did there is I figured out the first 9 terms there. So if I would have kept going, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth term, added them all up, and I get 403,53606. The reason this formula is nice is so you don't have to sit there and find the first 9 terms. This formula makes it easier to find that sum without having to find every single term. Because if I had to find the sum of the first 50 terms, that would have taken a while to write out the 50 terms, then add them all up and get my number. So that was the sum of a finite geometric series.